Hello, and welcome to the next exciting installment of Digital Design. The topic of this video is number systems, in particular binary numbers. So we're all accustomed to working with decimal numbers, or base 10. These are numbers where each column has 10 times the weight of the previous. So for example, consider the number 5374. We'll put a subscript 10 after it to indicate that this is in base 10, or decimal. The columns are the ones column, the tens column, the hundreds column, and the thousands column. Each column has 10 times the weight of the previous. So this number is 5 in the thousands column, 3 in the hundreds column, 7 in the tens column, and 4 in the ones column, or 5,374. In binary, we only have two possibilities, 0 or 1. So each column has twice the weight of the previous column. Now we have a 1's column, a 2's column, a 4's column, and an 8's column. So the number 1101 in binary, with a subscript 2 to remind us that it's binary, is 1, 8, plus 1 in the 4's column, plus 0 in the 2's column, plus 1 in the 1's column, which is 8 plus 4 plus 1, or 13 in decimal. As you could guess, we use powers of 2 quite a bit in binary, and it's handy to memorize these. You'll use them so much. So remember, anything to the 0 power is just 1. 2 to the 1 power is 2. 2 to the 2 power is 2 times 2, which is 4. 2 to the 3rd power is 2 times 2 times 2, which is 8. 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, 16384, and 32768. Let's talk about converting numbers between binary and decimal. So for example, if we had the number 10011, this is the 1's column, 2's, 4's, 8's, and 16's. So this is 16 plus 2 plus 1, which is 19 in decimal. We can also go the other way, converting from decimal to binary. So let's say we had the number 47 in decimal. We could start with the largest power of 2 that's smaller than our number. So that would be 32. Then our columns would be 16, 8, 4, 2, and 1. We need a 1 in the 32's column. So 47 take away 32 gives us 15. 15 is less than 16, so we don't need any 16s. 8 is less than 15, so we need 1 8, leaving 7. 4 is less than 7, so we need a 4, leaving 3. 2 is less than 3. Oops. So we need a 2, and that leaves 1, so we need a 1. So this is 32 plus 8 plus 4 plus 2 plus 1 equals 47. Or we could rewrite it more compactly, 101111 in binary. So there are two general methods of converting from decimal to binary. One is the method that we just tried, finding the largest power of 2 that fits, subtracting it off and repeating. Another method that's more suitable for computers often is to repeatedly divide by 2, and the remainder going in the next most significant bit. So let's suppose we wanted to convert 53 to binary. Again, we have the 32, 16, 8, 4, 2, and 1. 32 is less than 53, so we need one of those. Leaving 21. We need a 16. Leaving 5, so we don't need any 8s. We need a 4, leaving 1, so we don't need any 2's, and now we need a 1. So 1, 1, 0, 1, 0, 1. Alternatively, we'll divide by 2, and the remainder going in the next most significant bit. So 53 divided by 2 is 26 remainder 1, so that 1 goes in the bottom bit. 26 divided by 2 is 13 remainder 0, so we get a 0. 13 divided by 2 is 6 remainder 1, so we need a 1. 6 divided by 2 is 3 remainder 0, so we get a 0. 3 divided by 2 is 1 remainder 1, and 1 divided by 2 is 0 remainder 1. So again, we get 1, 1, 0, 1, 0, 1. Both will work. I tend to use method 1 as a human, that's more natural to me. Finally, let's think about the range of numbers that we could represent in binary. And for starters, let's think about this in decimal. So suppose we had an n-digit decimal number. There are 10 to the n different numbers in the range of 0 to 10 to the n minus 1. So example, a 3-digit decimal number has 1,000 different possibilities from 0 to 999. If we have an n-bit binary number, by analogy, there are 2 to the n possible numbers in the range of 0 to 2 to the n minus 1. So for example, a 3-bit binary number, there are 8 possibilities from 000 to 111, or in decimal, that's from 0 to 7.